is Old Electronics Fan, and this is another of the items I got recently after some guy passed away. And I thought this was interesting, and I wanted to check it out. And oops, look at that. And I've never used one of these before. This is old. I'm not sure how old it is. Oh, yeah, it tells me copyright 1988, so not exactly current product. So I didn't really think there'd be much of interest in here to really record. I was just going to go in, put a battery in. This is the battery that was in it. And as you can tell from the back of it, the adhesive they used was pretty sturdy. I haven't cleaned this off at all, as you can well see. Come on. We'll just quickly dust it off a little bit. I still have to do more cleaning later, but get rid of the loose dust anyway. Alright. Now, when I was playing with this before, I pretty much assumed let's see, alright. You see down here at the bottom it says diode, and I pretty much assumed that these two leads are for the diode, and that's what the manual says, the black and the red. I put it in diode mode. Let's find a diode. I happen to have one right here, and so come on, you. A little stiff. Now, if I push this, and it is working. And assuming that if I swap these two leads, it'll light up the other light. So it says either light. And it does. Okay. Good. Now, okay. So I need to find a transistor and find out which, let's see, yeah, I can use these leads for that. I've got a little socket here that you can plug a transistor into, but alright, I'm going to round up a transistor and make sure I know which is which. And I can use my other tool for that. So I've got this, and I can tell which one is which, and I don't really care what transistor but I use, but I'm going to go emitter, base, collector. So my cheat sheet, because I forget things easily. I'll read something and then what did I read? Alright, miscellaneous transistors, okay, that should do, and NPN, that's what those are listed as, so let's grab one of these, alright, so these are numbered on the circuit board so I know that which one is which. It goes 1, 2, 3, left to right, and alright, so okay, so 1 is emitter, and 2 is the collector, and 3 is the base. Now that we have that, now I believe it says an NPN, so I want to hook this up so that the emitter is this one, and then the collector is the middle one, and then try to avoid having them touch. Now, so NPN. Okay, now they say something about base current control, and we put that on transistor. So I've got it set to NPN. Base current right now is 0. Let's see what it says about that, because I've not read my instructions yet. Okay, identifies NPN. Okay. High gain circuit, in circuits with a base. Okay, so this can actually test in circuit apparently, with resistances as low as 100 ohms. So, okay, diode. Okay, out of circuit. Let's switch transistor. Okay, yeah. Adjust the base current so the OK current lights up. OK lamp. Okay. Well, that's interesting. On here, the middle light is OK. On here, it says on. Now, all right, so I'm going to do this. And I don't know. So it tells you NPN. Huh. This one is different. So it tells me it's NPN, and if I control the base current, it's almost at full. If I don't do anything, the light doesn't come on. So this on light is not, these instructions are not for this version, apparently. Huh. Well, that's interesting. I may have to explore that some more. Alright, so it says, if the OK lamp doesn't light, adjust the base current so that either NPN or PNP LED lights up. This happens at the minimum or maximum position of the control setting. This will indicate the transistor type. Okay. When the transistor is shown to be OK, the base current control gives an indication of the transistor beta. Lower the setting relative to another transistor, the higher the beta. Lamps NPN and PNP measure base current. Higher base current results in a brighter LED. Also indicates if current is entering or leaving the base. Thus, okay. Okay. Well, I'm not entirely clear about what's going on here, because I've got NPN, and I hit this, and that light comes on, and if I max it out, that goes as bright as it's going to be, of course. It's in transistor mode. So I don't know, I mean, on the model that's in this book, that says OK. This says on, which is less than helpful. I'm assuming, since this is a transistor tester, OK means the transistor is OK. Now, I've already tested this transistor in that, and it tells me that the transistor is fine. Let's try a different transistor. I may have to dig around and see if I can find a different manual. This may be a variation. And this is a DT100. See what that says. But it's not lining up. Okay. Okay, it's got a schematic and everything somewhere. And it's all transistor logic. No ICs in this thing. Huh. Well, maybe I should try to explore that and see if that matches this, but I think the first thing I'm going to do is try to find out whether or not there is a variant on these. that I can look up, or that I can use, put it that way. Well, let's see, what was this? This was, it's a transistor I don't recognize. Well, anyway, let's make sure I have it. I think these go in there. We're going to have to do the same thing. Well, let's see if I got that one right. And it should be NPN, I think. Okay. And you're saying, well, you've already got a tester, it's working. But if this can test transistors in circuit, that could be helpful, which they're claiming it can. So base, yep, and then collector. What do I do? Collector, emitter. Okay, yes, that is emitter. Yes. All right. And so I'm going to shoot that with some cleaner. I don't think I have a problem with that, but it never hurts. Yeah. Let's see. You should shoot both of them. Why not? There's rust on both of well, on the NPN PNP switch. There's rust, and that does not excite me. All right. I'm assuming this one's okay because it worked. It told me when I was in, or it worked when I put it in diode, and it worked when I put it in transistor. So right, now we're there, and yes. Well, I say well. An interesting device. I'm puzzled as to why the on light isn't turning on. Because definitely this is working, and I'm not seeing any control. Feels decent actually. I don't see anything to tell me that the control is dirty. I'm not sure how much of that you're seeing. The control actually feels really nice. It's a little bit stiff, but yeah. I'm going to have to investigate this further because I don't really know why this one doesn't have an OK light and why the OK light isn't turning on. The fact that the NPN light is turning on tells me that at least at a basic level this is working. Okay, theory of operation. I'll have to read that through better. Checking out. Short yellow and black leads together. Yellow and black. Okay. And one light should light up, and it does. All right. You should read the entire instructions on testing things before you assume you're doing it wrong or that it's not working. So, if I push this in and nothing happens, I'm supposed to rotate this and see if that works. And if I go that way, the other one works. So this is indeed working the way it was before I cleaned it, it would seem. So the on light never turns on. So what does the test say it will do? So it says, alright, now place a known good transistor in the test socket. Make sure none of the leads are shorting. Vary the base current control. The OK light should light up. Base current control should be adjusted for the lowest setting with the OK lamp glowing. So, really? Why? I want to look into why the instructions for this and the picture for this are not the same as this. And this light isn't turning on, so that could either mean that there is something wrong with this. Well, I have an oscilloscope that's new to me, and I'm learning that, which is fun. And this is this circuit I have not worked with before, but it is what it is, so I'm trying to sort it out. Now, this is supposed to be sending out an oscillation up here and down here to the base of this transistor. And I have my, I think it's probably connected here, but I should have oscillation here or here, since this capacitor will let it go through. So, let's check that out. So I've got this ready to go. It's nice, it's convenient to have something that's you can bring right up close. Alright, so now I'm going to press this, and I do have oscillation right there on that capacitor. And that's supposed to turn on. Let's unplug that for the moment. That's supposed to turn on the, let's see, okay, Q5, which is supposed to turn on this. Okay, so Q5 is there, and I want to trace that. Well, actually that, okay, so Q5 actually, I think, triggers, this is the plus 9 volts coming from the battery. When I hit this, 9 volts, it's in transistor mode, 9 volts goes up, flows through here, and it's sitting here waiting at this diode LED ready to go. What's supposed to happen is a signal turns this transistor on, which turns this one on. This acts as a switch, and then creates a path through the diode to ground. Yes, that would make sense. So, either this is not behaving, or this is not behaving. Or I've got a bad capacitor, who knows. So, alright, so there's the capacitor. But before I decide to condemn that poor capacitor, let's take a look. Huh. You gotta be kidding me. Okay. I'm looking this over. Alright. Oh boy. Okay. This comes two ways. This comes as a kit, or it comes as pre-made. And looking at this, I thought, the soldering is pretty good on this. This is probably done at the factory. Well, I don't know. I have seen soldering jobs this bad from the factory. So it's possible that that's my problem. Let's see if I can bring you in here to show what I've just spotted. I saw daylight coming through the board. Let's zoom in and see how far we get. Come on. Focus, please. Why are you not focusing? You're supposed to. Okay, there it is. That's what I want. Right there. See that? That looks like a bad solder joint. There's not much solder there. Okay. That's got me baffled. I don't know if this guy ever got this thing to work. Now my assumption is that even though this is saying on instead of OK, I actually saw a, oh, let me back up. I went looking for a different revision schematic for this board, actually for this unit. And I found one that actually showed the front cover saying on. And when I looked at the schematic, it looked just like this one. And there it is. I'll be darned. Yep. So, I think you can see that. Let's go with this. It's working now. So, if somebody built this themselves, and it looks a lot like they did, and they were using it as was, they were only using this to find out if it was an NPN or PNP transistor. Because, yeah, how about that? Well, let's back out a bit here. That was interesting. I really never expected to get into something like that. But what that means is that if your circuit or your panel says on instead of OK, well, this light means the same thing no matter how they've labeled it. So I don't know why they thought on was a good thing to do. It's really strange. But anyway, so this transistor was in my collection, and these have all been tested before they went in there, so I know it's good, and this agrees. So, and that was, oh, let's see. It was, yes. It was a PNP, yep. Alright, now let's do this for the fun of see if I can find an NPN. I don't know. Well, let's try this one. This one looks like I've played with it, and alright, I don't really know where anything is. If I'm right, this is the base. I'll put that on PNP. Come on. Alright. That part I know. And so this should be a base here. But we don't know that yet. And we'll find out that it is or isn't because the light won't turn on. And I don't know where the rest of them go, so we're just going to hook them up and see what happens. If I've got it right, I have lights. If I don't, then I have to reposition the base connection and try to find something that works. Alright, now, so, interesting. Well, the light works. And that's on NPN. I'll have to read the instruction books about why that goes out. But the fact is it works. And I do this, and then I go all the way down. So, yeah, so that's telling me that it likes the transistor. This tells me that I've got a certain amount of bias, which also tells me the gain, but I don't know why. Okay, that's almost maxed out. Interesting. Huh. Well, I hope that doesn't mean there's something else wrong. I didn't max out the other transistor. Let's, for the fun of it, swap these two. I don't think it's going to make a difference. but who knows. Trying to make sure those, alright. Are you getting short out? Don't do that. Alright, here we go. Well, it doesn't like that, so interesting. Alright. Yep, so it likes that much better. Now my other possibility is I could do this. This will probably stop it from working also. But let's see. Yeah, it does not like that. So the base was correct. If the base is not correct, then you get no lights, and that's what I wound up with. Yep. Interesting. Alright. I'll have to play around with that, but at least now it's doing stuff. Okay, well that was fun. Like I said, that wasn't what I really expected to run into. Let's take this one. I'm going to try this one again, because I think this is the one I had in there. And I think the base was in the middle, I think. We'll see. And this is going to be PNP. Base is yellow. And we'll do these two. And okay. Alright. So and it's doing the same thing basically. Interesting. I don't know if it's supposed to do that. So that light stays on until I get to max, and that light goes on brighter. Okay. Well, this was interesting. The instructions regarding this are less than clear. Depending on what part of the instructions you read, you're left with the idea that either this light is the one that you use for gauging base current and therefore the level of beta, or you use one of these. My ultimate conclusion is that you use these lights, and I'll show you that in a minute why. I have checked this thing out thoroughly from end to end. I've spent a fair amount of time, actually disconnected this capacitor and tested so let's look at this. This is the part that deals with transistor testing. All this stuff right here. This part has to do with diodes. But there's also two parts to this. This part has to do with the, actually now that makes sense. These lights, number one, can tell you if you have your setting down here incorrect. You either turn this control, the only pot on here, all the way to max or all the way to min, and if you've got this switch in the wrong position, one of these two lights will light up brightly, telling you what type of transistor you have in here, and then you can change the switch to the correct setting, and now when you adjust this light and the OK light, or in my case on light, will then come on. Now, I have tested every way I know how, and there's absolutely nothing wrong with this. I thought there was, because when you turn this control to the max, this light goes out. These lights stay on. So I thought there was something wrong with this. Well, what is wrong with this is the instructions. So let's see here. Okay. So let me find the pages that I want to use. Okay. I feel like I should write my own instructions. All right. So, checking out your transistor tester. I mean, this sentence makes no sense. All right. The OK light LED should light up. Note that the NPN transistor, the NPN lamp will also glow very slightly. This indicates base current and thus lower intensity. That doesn't entirely add up. Base current control should be adjusted for the lowest setting with the OK lamp glowing. Now, I believe that's the key to understanding how to use this to check the beta. Now, page 4. Actually, there it is. I was looking for this earlier. Let's see. Okay. All right. The lower the base current, the higher the gain of the transistor under test. Can be made by observing the dial setting on or the intensity of the base LED diode. The lower the setting in with the PNP LED lit, the higher the beta of the transistor. Somebody should really rewrite this because it's not making sense. Because what they're doing is they're confusing me. Let me go to this. When they said base LED, I assumed that was the one they're talking about. It's not. Well, these two are the ones, if you look at the circuit diagram, these are the two. There's the transistor under test. There's your base. This is the base potentiometer. These are the two LEDs that tell you what base current this transistor is drawing. This is primarily there to tell you that this transistor is working. Okay, I've got this assembled. Since I've decided there's nothing wrong with it, I've also made a modification. I put new ends on. The clip leads were just annoying. Sometimes they wouldn't even grip the thin wire of the transistor and they'd slide off, or they'd try to short, or whatever. They're just a pain. And the plastic covering that's on the clip leads is hard, which means this thing's been around for a long time, and so that didn't want to really behave the way it should. So anyway, so if you get one of these, I actually did test this or actually used this to test a piece of equipment to see if a transistor was good, and this told me it was, which led me on to find the real problem with it. So let's see, what do I want to do? Okay. Based on what I understand about the instructions, I should be able, so I've got two transistors here. I've got one, I've got a beta of 431, and I've got one that's got a beta of 140. And the transistor I have in there now is the 440. Yeah, so this one has a beta of 140. This is a PNP, and it should work for either one. But so here's how it's supposed to work. So I turn this on, I turn this up, the light turns on, and I keep going until this light, now theoretically they said keep this at the minimum possible. So as far as I can tell, the light isn't really on here. It's hard to tell when this turns on if this is getting reflected light, but I'm going to keep going until I can tell that it's on. So that says 50, so we're going to put that down here. Alright. Now we're going to put the other transistor on here, and we're going to see because there's a fair amount of difference between 431 and 140, we should find out whether or not, or should be able to tell whether or not this method of checking beta works. So this is a 557, so this is emitter. Come on, you. Alright. And we want emitter, base collector. Base is yellow. And collector. And I think we're pretty good. So now we do this. Now theoretically this should come on, and it's not. It's coming way. I don't get a good response out of this until about 60. Well, no, it's not right. It's about the same. Like 45 maybe. 40. All right, so this one is 40. 40 that. So if I remember right, this says that the lower the number, the higher the gain. Yes, the lower the base current, the higher the gain. Now, I wouldn't use this to accurately determine which one has higher gain or not. So as I thought about this, I said, well, what if I do this? I've got my Beckman here, and I'm going to, what did I do? Where's my cable? Let's see. Well, I guess it doesn't really matter. But. So what I'm going to do is I'm going to take this off from here, my base lead, I'm going to put it over here. And it really doesn't matter if the meter says reverse or if it says negative versus positive. I don't really care about that. I just want a number. Alright, so here we are. I'm on my 2 milliamp range. I turn this on, and I'm interrupting the video at that point. I spent a lot of time playing with this and this, and I came to a conclusion. Well, I did make a change. Originally, I was going to use this control to see the difference on the control. So, say I hit 20 milliamps at 60 on one transistor and at 70 on another. That would give me an idea of the difference between. But this is so touchy. This would dance around all over the place. So what I did was I picked a number that seemed to be enough current that there was a good chance that there would be a difference between the two resistors. And I had these two transistors, not resistors, transistors. I misspoke. And one had, this one was 57 for the beta, and this one was 9208, 285. So there's a significant difference between the two. After all my playing around, I discovered, so I set it to 70, I read one, I think it was the, the tip. So the tip was 234 milliamps. The 9208 was 221 milliamps. So what are we talking, 13 milliamp difference between the two? And the difference between the two transistors is significant. So I don't know if this is working correctly. I think I've mentioned this already in the previous part of my recording. but I'm spending a lot of time on something that I'm never ever going to use. It's too fiddly. Even using this, the results you get are less than stellar. Is it unique to my unit? I don't really know. So, if somebody out there has one of these and has successfully used it to compare beta, it'd be interesting to hear. I, myself, have decided that that feature is not so hot. Now, whoever designed this was very clever, and now this is pretty simple, a pretty simple schematic. Yeah. The design of this is pretty interesting. So let me go over a couple things again. I'm sure I'm going to be duplicating what I've already done, but I'm going to wrap up with this part. I'm not paying attention to where I am, and let me do this. I'm going to position this. When I get talking about things and thinking about what I'm talking about, I don't pay a bit of attention to the camera. Alright, let's try this again. Alright. So, I didn't understand my instructions. I really should have looked at the schematic more closely. Oh, I looked at it, but I didn't think about what it was telling me. So yeah. You've got two parts to this. This is the part that manages the OK light. This is the part that's supposed to be for the beta, and it also tells you if you have the NPN-PNP switch. Yeah. If you have this switch in the wrong position, say you have an NPN transistor here, you've got it set to PNP, rotating the control either max one direction or the other will light up one of these two lights, and it will tell you which transistor you're actually working with, and you can change your setting. Once you get this set correctly, then the correct light will light up here when you turn the control far enough. This light will usually turn on first, and the purpose of this light is to tell you if this transistor is working or not. And then, as you continue, one of these two lights, depending on which transistor you have in there, will light up. And this is where the beta measurement comes in. And the instructions do say at one point, you want to keep this control at the minimum you can, which means you want to turn it until one of these, whichever light you're working with, just turns on. I have spent a whole bunch of time, and I even, as you just saw, tried using my meter to measure the current, because I'm puzzled. I said, well, why is this so useless? Why is it not showing me a bigger difference between transistors? Because that transistor that I was just mentioning one was 47 or 57 for the beta, and the other one was 285. That's a significant difference, but this barely measured a current difference. I don't know if these LEDs are the reason for that, or if there's something else. At this point, I've really stopped trying to figure that out. So, the last thing I tried, and I don't know if I just mentioned this or not, the last thing I tried was I set this on 70. The reason I set this at a fixed point was because this is so touchy. The readings on the meter were dancing all over the place. And at 70, it seemed like it was drawing enough current so that if there was a difference in the current draw between transistors, that was a good point to see it without it being excessive. And the result, well, less than great. The tip read 234 milliamps. The 9208 read 221 milliamps. The difference between the two is only 13. That's just not useful. So if somebody has one of these and they are able to successfully use that, I would be interested to know. But at this point, given what's available to us today, all the tools that we have available to give us the beta, and we've got basic tools like this, which, while they aren't exact, they aren't precise, and I seem to recall they don't give the exact same beta each time you test. They're close enough, and if you're trying to do a matched set of transistors, you can probably use this. If you want to get more sophisticated, there are circuit tracers, transistor circuit tracers around. You can invest in one of those, and then you can read what you need to from one of those. Not transmit. What do they call those? Curve tracers. So you can get a curve tracer. Probably even build one. I think there's the way information on that on the web. Usually in YouTube. And so build a curve tracer, and then you can measure what you will need to measure, so you can match up your transistors, say in a push-pull circuit. So I'm giving up on this. I don't really know why it's not working the way it should on mine, but it isn't, and I'm done. Now, this has been useful for me. Let me explain something. I've been working on electronics since I was 15, thereabouts. And I even went to school. I started to go to school for electronics, and then decided the math was just more than I wanted to tangle. Mathematics is not my strong suit. I can add and divide and multiply easily enough, but when you get into calculus and determinants and all that other stuff, I just decided that wasn't for me, so I went and did something else. I'm still not sure if that was a good decision, but that's what I did. And there's also a 20-year or so span where I didn't do anything with electronics, and then I got back into my hobby a few years ago and discovered I'd forgotten a lot. It's kind of disappointing, because there's a lot of stuff that I used to know that I just don't remember anymore. 20 or 30 years is a long time to not do something and you forget. So I'm kind of rebuilding what I know. I'm kind of reminding myself of what I used to know, and I'm learning more stuff. So playing with this was good for me, because mostly I play with tube stuff. Getting into transistor stuff is something I know about, but because I've done so little with it over the years, I've forgotten too much of it. But this was good for me, and there's a lot of stuff that I'm starting to relearn, and a lot of stuff I'm being reminded of. So bear with me as I continue to learn. This is one of the reasons why I do this. I hope that the stuff I do know is helpful to those who watch. But I also learn from those, even the negative comments, those who watch and comment. So I definitely encourage that, even if you're not happy with me. I learn from that, and I try to do better, and I try to gain more knowledge, so that I get fewer critical comments. Plus, I want to know more. I used to know more. So anyway, let me move forward. So, as I'm exploring this circuit, okay, so I remember, yeah, so this light would go out when you max this. So what was happening? This was drawing way too much current when the bias was too high. The voltage drop across this almost went to full voltage. The power supply was, by the time the voltage got here, I think you were looking at 8.4, something like that. I think the battery's been used a lot, and so it's starting to lose voltage. But when I was testing, the battery voltage was around 8.4, 8.5, something like that, if you measure here. When I was measuring here, with this at max, I was getting, like I said, 0.1, 2.3. So why was that a problem for the rest of the circuit? Well, this is a classic amplifier right here. A lot of A lot of amplifiers are common emitter, so it's a classic design. Both of these transistors are amplifier transistors. That's what they're typically used for, and they're the same transistor. And so this one actually feeds the base from the collector, and then that feeds, then the emitter actually feeds the base of this transistor. And the creative part of this, well, where am I headed? Okay, so what's supposed to happen is signal goes into here, and I say signal because that's what it is. You'll see in a minute. Signal comes in here, this transistor turns on, feeds signal to this transistor, this turns on, and sends signal to here, which turns this on, which then turns this on, which turns on the OK light. Now, I mentioned that the OK light tells you that this transistor is operating. Well, what happens when the voltage at this point drops so low that there is no longer enough voltage for this transistor to operate correctly? I believe what was happening is the voltage was getting so low that this stopped oscillating. Because this has a feedback circuit right here. And so what happens, signal feed goes to here, feeds back to here, and you get an oscillation happening in here. That's important. It's important for a couple of reasons. Number one, what would happen if the base shorted to the collector and you were just using straight DC voltage here to turn on this transistor? With a shorted transistor, this light could still turn on. But because you have a capacitor in here, a shorted base collector connection would, number one, stop this from being a transistor, and because the capacitor's there, you would have straight DC voltage here. There would be no sine wave, there would be no oscillation. Therefore, the DC voltage would stop here, the rest of this would shut off, or it would never turn on. So that's a clever piece to make sure that no matter how this transistor fails, any failure that prevents this transistor from being a transistor means that this light will never turn on, because this transistor has to operate, and it has to be able to be part of an oscillation. That's got to be it's got to be I guess it's supposed to become an oscillator. That's what the circuit really is, in order for that light to turn on. And you'll notice as you turn the base control up, there comes a point at which this transistor starts conducting, and then you have the signal flowing that's sufficient to turn this on. So that explains why that light was turning off at max, which makes sense. And they also have a capacitor in here, which 0.01, so that's probably intended to make sure that any DC volts doesn't make it back onto here. All you want is the signal, the sine wave, to make its way back here and keep that oscillation going. So there's that. So it's a simple, very elegant circuit. They figured out how to make sure that the transistor is actually turning on and operating, and that this light only turns on when that happens. So it's a good design. So the part I still really don't understand, I understand the basics. This, again, is just designed to control the current flowing through the circuit to make sure it doesn't get too high, and it could without that there. I wish I had spent a little bit more time exploring this and paying attention to how this works. Then I would have known, as bad as the instructions are, I would have known how they were supposed to work. This tells you everything you need to know. And I'm going to try to pay attention to that in the future if I come up against instructions that don't make sense. I'm going to have to go back to the schematic if I have it and try to explore what the circuit's actually doing so I can make sense of the instructions if they are less than clear. And the other part of this is interesting. They use the 555 chip as an oscillator, and that's for the diode part of the circuit. And I'll leave that up to you to explore that. This works fine. When you're testing this, these alternate back and forth because you short two leads together. You put, and on mine, this always worked. This part was always functional and no trouble whatsoever. So this part, I don't know. I'm still kind of puzzled at whoever built this, because it looks like somebody did build it. I don't know if they wound up simply using it for checking diodes, because it really couldn't be used as a transistor checker. That, by the way, is probably the only thing I will use this for. I've got a good meter collection, probably more than I need, that will help me test whether or not an LED is functional. Now, I suppose if you want to test an LED in a live circuit, you could use this for that as well. And maybe I can't remember if I've ever run into a diode that would test okay on the meter but not work in circuit. But you could certainly use this to test that, because if the diode did have that problem, it probably would not function in this circuit. So that's another possibility. So it's an interesting little circuit. I've been both frustrated by this, but also intrigued by it, and I have actually enjoyed learning what I've learned. And like I said, I have used this to test a transistor in circuit, and from what I can tell, it gave me the correct information. And I could see this being very useful in the future if I want to test and troubleshoot a circuit to see if I've got a failing transistor or a failed transistor somewhere. Now, I know that what the heck is his name? Dr. Paul somebody or other. I can't remember why I don't remember the name of his channel. I watch it often enough. But he's got the super probe and some other electronic testing equipment that you can build. Very, very, very useful, and probably an easy way to, well, a much faster way to troubleshoot things. And so one of these days, when I feel like I'm going to have the time to invest in something and learning from him, I might do that. I might join his course and build some of the electronics that he offers, and make my life a lot easier when I'm troubleshooting things. But for the moment, I got stuff like this that will at least get me somewhere part of the way there. Like I said, it did help me when I was troubleshooting something already. So that's how I'm going to use it. That Carlson's Lab, that's who that is. I don't know why I didn't remember that. So Carlson's Lab he knows so much about electronics. Wish I knew a small portion of what he knows. But anyway, so I'm going to wrap up at this point. I hope you enjoyed this. Hope this was helpful. If you liked it, give me a like. Comments, again, I appreciate those. And of course, I really like it when you subscribe. That helps me know I'm doing the right thing, that the stuff I'm putting out people like and are willing to join my channel for. So anyway, I'm wrapping up here, and I thank you for watching this far. Hope to see you next time.